Many of the materials we work with in our labs give off fumes, mists, vapors, particulates, or aerosols that are hazardous. To minimize exposure to these materials, we need to take special precautions. Often, this means working within a hood. We can get an idea of how to work safely with hoods by looking at one of the most frequently used types, the chemical exhaust hood. Exhaust hoods protect us by preventing contaminants within the hood from entering our breathing zone. A protective barrier is created by air that's pulled into and through the hood. This inward airflow helps keep hazardous fumes and vapors from escaping and reaching anyone outside the hood. Contaminants that are captured within the airflow are filtered, diluted, and exhausted through the hood's duct system. This air is then sent outside the building, where the contaminants are further diluted into the atmosphere. Hoods also protect the operator from other physical threats. The sash provides protection from hazards like chemical splashes and sprays, as well as fires and minor explosions. Generally, you want to pull the sash down as far as possible while keeping it at a level that allows you to work comfortably. Many hood manufacturers have determined the levels at which the sashes in their hoods should be placed for maximum protection, so you'll want to follow their recommendations if at all possible. When working within a hood, don't forget to wear the personal protective equipment that the materials you're using call for. Even with a hood's protection, you need to wear at least the safety eyewear, lab coat, and gloves that you normally use. And if the substances you're working with require additional protection, you should use it as well. To ensure that it's operating safely, each lab hood is thoroughly tested when it's first installed, whenever there's a change in the ventilation system, and on a regular basis thereafter. There are specific steps that need to be taken to determine if a hood is operating the way it should. First, the air circulation around the hood should be checked. Your supervisor or a qualified engineer will measure the flow of air 6 inches in front of the hood. This cross draft should be monitored carefully. Drafts greater than 20 linear feet per minute will adversely affect the performance of the hood. Next, a smoke tube should be used to make sure that the air is flowing as it should inside the hood. If the smoke heads for the ventilation ducts, then the hood is operating correctly. It's then time to open the sash and measure the rate of air coming through the face of the hood. This measurement is known as the hood's face velocity. An accurate measurement of the face velocity is very important, so a precision instrument like an anemometer or velometer should be used. Never try to use something like sheets of tissue paper to give you an indication of face velocity. They will only show you whether the hood is on or off. When measuring face velocity, the sash should be adjusted as if you were about to begin work. Your supervisor will divide the hood face into a grid pattern and measure the velocity of the air in each section. Values at specific points may vary by plus or minus 25% without compromising the safety of the hood's operation. But no measurement should be below 60 linear feet per minute. If your test shows a lower speed, the airflow should be adjusted before the hood is used again. Your supervisor will also compare the face velocity of the air coming through the hood with the speed of the cross draft to make sure that the cross draft is never greater than 20% of the face velocity. If this is a problem, the interior hood baffle will be adjusted, or if necessary, the ventilation of the laboratory itself may need to be altered. In general, hoods will bring in air at a face velocity of about 80 to 100 linear feet per minute. But you may need to use a higher velocity for some of the work that you do. A velocity of about 125 linear feet per minute may be required for some procedures. Be careful though. Higher velocities can create turbulence both inside a hood and at the front of the hood face. This can cause vapors within the hood to spill out into the laboratory, putting you and your coworkers at risk. In general, face velocity should not exceed 150 linear feet per minute. And remember, you should have the face velocity of your hoods measured regularly, once a year at minimum. Once it's determined that the air velocities in and around the hood are within accepted ranges, it's important to make sure the hood is relatively free of air turbulence. Turbulence can be checked by observing smoke patterns within the hood. If there's excessive turbulence or if the hood fails to capture the smoke, adjustments will be required. The engineer who is working on the hood will consider changing a number of things, such as the location of equipment within the hood, the hood's face velocity, the location of air input ports, the physical location of the hood, and the volume of air being brought into the hood. As you can see, there is a lot that goes into making sure that a hood is functioning properly. If you suspect that your hood isn't performing as it should, talk to your supervisor to determine if a reevaluation is needed. Having a lab hood set up correctly is just half the battle. In order for hoods to be effective, we've also got to use them correctly. This means doing everything we can to maintain proper airflow within the hood. To begin with, the work you do should be performed at least 6 inches inside the hood. This enables the airflow within the hood to capture any dangerous vapors and particles near the face and prevent them from escaping into your breathing zone. Since large pieces of equipment such as orbital shakers can obstruct the airflow within a hood, they should be elevated to allow air to pass under them. Never use hoods as storage cabinets. Overloading a hood restricts its airflow and can result in the dangerous buildup of hazardous vapors. Additionally, chemicals that are stored inside a hood can make an incident such as a spill or fire even worse. So if you're not actively working with a chemical, put it in its normal storage space. You should also keep the sash closed as much as possible when you're not working in your hood. Remember to consult the manufacturer's recommendations. And pay attention to the hood's own air monitors. They'll warn you when the airflow through the hood isn't strong enough to contain the hazards within it. It's important to be careful about how you move when you're in front of a hood as well. Even face velocities of 100 linear feet per minute can easily be disrupted by rapidly removing your arms from inside a hood. Even just walking by the hood face can cause problems. So you need to be careful of any physical movements you make that might alter a hood's airflow. After all, most hoods aren't even as powerful as a vacuum cleaner. Another thing you need to guard against is solid objects, such as papers entering the exhaust ducts of a hood. If they lodge in the ducts or the hood's fans, it will significantly degrade the effectiveness of the hood. And never place your head inside an exhaust hood. Not only will it disrupt the airflow, you could be overcome by hazardous fumes or vapors. If you need to make adjustments inside the hood, talk to your supervisor. Most of the hoods we work with are designed to keep us from breathing in hazardous fumes and vapors. However, there are also hoods that are built to take care of hazardous particles. Biohazard hoods, for example, are designed to capture toxic and infectious particulates. These types of hoods are most often used with work involving clinical specimens or body fluids. The major difference in these particulate cabinets is their filtering systems. Not only are these systems able to capture very fine particles and aerosols, but they don't evacuate these contaminants into the outside air. The most effective of these systems is the high-efficiency particulate air HEPA filter. A HEPA filter captures particulates as small as 0.3 of a micron at a success rate of 99.99%. Remember though, the HEPA filter is a particulate filter. It does not prevent hazardous gases from passing through the exhaust system. If the substances you're working with give off hazardous particles and gases, talk to your supervisor about which hoods in your lab will protect you from both hazards. There are hoods that provide protection against other specialized hazards as well. While you may not normally use them, you should know what they are there for and how they work. The most common of these hoods are used with perchloric acids and radioisotopes. The distinguishing feature of a perchloric acid hood is its washdown capability. This prevents the dangerous buildup of reactive residues. One thing to remember, organic materials should never be used in perchloric acid hoods. An explosive reaction may result from the mixture of organics and the acid's residue. If you're working with material that is radioactive, you should be using a radioisotope hood. This hood is impermeable to radioactive material and will minimize dangerous exposure. No matter what type of hood you're using or how many precautions you take, things can still go wrong. So it's important to be prepared in the event a hood-related accident occurs in your lab. Spills inside a hood need to be dealt with immediately. Follow your facility's cleanup procedures. Soak up the spill with an absorbent material and dispose of it properly. Small fires in a hood can be put out with extinguishers or through suffocation by covering them with a watch glass or inverted beaker. Some hoods even have their own fire suppression systems. With them, all you have to do is flick a switch. But in any case, you should know where the nearest fire extinguisher is in your lab. In the event of an uncontrollable fire, close the sash and get out. Sound the alarm and call the fire department. Ventilation failures are another type of emergency that you should be prepared for. A motor failure or malfunction in the electrical lines can bring your hood's ventilation system to a standstill, releasing harmful fumes, vapors, and particles in the process. Talk to your supervisor about your facility's emergency plan so that you'll know exactly what to do in case of an equipment failure or other ventilation problem. You can never be too careful when using a laboratory hood. Remember, the reason you're working under a hood is that you're handling substances that are hazardous. Let's review. Make sure the hoods you work with are set up correctly and that they meet all performance requirements. Keep all of your work at least 6 inches inside the hood. Don't use your hood as a storage cabinet. Too many objects inside a hood can distort its airflow. Pay attention to your airflow monitors and keep the hood sash down as far as possible when you work. Be sure your hood is checked or recertified regularly. And be prepared in case of a hood-related emergency. Choosing the right hood for the job and working with it correctly will isolate the contaminants your work may generate and keep you and your coworkers safe.